Welcome to the GCSE Maths Advantage. I'm Dr. James Carter, and every episode I'm going to break down one topic, show you where the marks are, and give you a quick win you can use in your next exam. Whether you're targeting a grade 7 or pushing for a 9, let's get into it.
Hook. This one question lost more marks than any other on last year's papers, a linear and a quadratic that intersect. Students used the wrong method, made sign errors, and forgot to check their answers. The scary part, every mark was perfectly recoverable if they'd followed one simple decision rule.
Sound familiar? I remember doing loads of algebra and still messing that up in the exam. Tell me the rule, Dr. Carter. I don't want to lose those marks again. Good. Here's the decision tree you must memorize. If both equations are linear, use elimination. If one is linear and the other is quadratic, use substitution into the quadratic. If the numbers look messy or you want a quick check, sketch the graphs. That rule saves time and avoids mixing methods midway. Why elimination for linear-linear? Because elimination targets coefficients. You use addition or subtraction to remove one variable immediately, giving a single linear equation that you can solve quickly. It minimizes algebraic manipulation, so fewer opportunities to drop a sign. Why substitution for linear-quadratic? Because the linear equation expresses one variable in terms of the other. That expression slots neatly into the quadratic and produces a single variable quadratic, which we can solve using factorization, completing the square, or the quadratic formula.
So I shouldn't try elimination on a linear-quadratic pair. I tried that once and things got messy.
Exactly. You can, but it usually introduces fractions or awkward algebra. Substitution keeps the work organized and makes it easier to show the examiner your method. Let's do 2 worked examples step by step so the rule sticks.
Example 1. Linear-linear. Solve 2x plus 3y equals 8 and x minus 2y equals 1. First, pick elimination. I'll multiply the second equation by 2 so the x terms line up. 2x plus 3y equals 8 and 2x minus 4y equals 2. Now subtract the second from the first to eliminate x. 2x plus 3y minus 2x minus 4y equals 8 minus 2, which gives 7y equals 6, so y equals 6/7.
Then substitute y back into x minus 2y equals 1. X minus 2 times 7/7 equals 1. So x minus 12/7 equals 1. X equals 1 plus 12/7 equals 19/7. Write the answer as 19/7, 6/7. Crucial, label your step where you eliminated x and where you substituted back. Examiners love that.
That was neat. I can see the marks. One for eliminating, one for solving y, and one for substituting back. Exactly. For a 3-mark linear-linear question, you'll typically see M1 for a correct elimination setup, M1 for correct method to a numerical value, and A1 for the final correct pair. If intermediate values are shown clearly, you can earn method marks even if the final value is slip-shown. Now, example 2. Linear-quadratic. Solve y equals 2x minus 1 and x squared plus y minus 6 equals 0. Use substitution. Replace y in the quadratic with 2x minus 1. That gives x squared plus 2x minus 1 minus 6 equals 0. Simplify to x squared plus 2x minus 7 equals 0. Now, solve the quadratic. It doesn't factor nicely, so use the quadratic formula. X equals minus 2 plus or minus square root of 4 plus 28 equals minus 2 plus or minus square root of 32 equals minus 2 plus or minus 4 square roots of 2 equals minus 1 plus or minus 2 square roots of 2. 2 x values. Then find the matching y by substituting each x back into y equals 2x minus 1. Show each substitute step clearly.
So substitution keeps the quadratic neat and shows exactly how you found the x values. That sounds safer than juggling both equations together.
Right. And here's the examiner view on these questions. They award method marks for correct algebraic manipulations and accuracy marks for final values. If you show substitution and the quadratic you formed, you bank method marks even if you slip the final arithmetic.
Common mark allocations. A typical linear quadratic question might be 4 marks, M1 for substitution, M1 for correct rearrangement to a quadratic, M1 for a correct solution method to that quadratic, and A1 for the correct ordered pairs. If you show intermediate substitution and your working is consistent, partial credit is awarded.
Now, the mistakes that lose marks: dropping signs when substituting, failing to simplify the quadratic correctly, and the big one, not substituting your final x back to find y. If you stop at x, you often lose the final accuracy mark, and you leave the examiner guessing. I always forget that last step when I'm rushing. Any quick habits to stop that?
Yes, the quick win. A 10-second checklist you can run on every simultaneous equation question. 1. Label your variables. 2. Decide method by structure. Linear, use elimination. Linear quadratic, use substitution. 3. Write the substitution line clearly. 4. Box intermediate values. 5. Always substitute back for the other variable and tick your final answer. Repeat that checklist silently before you move on. Also a discriminant trick. After substitution, compute the discriminant d equals b squared minus 4ac of the quadratic. If d greater than 0, you get 2 real intersections. D equals 0 gives 1 repeated intersection. D less than 0 means no real intersections. That's a fast check to see whether you should expect 2 answers or none. Use it in the exam to sanity check your results.
That's brilliant. A quick check to avoid hunting for answers that aren't there. OK, worked example you can try. I'm going to read a question, then pause for you to try it. Question. Solve the system y equals x plus 3 and x squared plus y equals 7. Pause the podcast now and try substitution for 20 seconds. Ready? Go.
Back. Great. If you substituted y equals x plus 3 into x squared plus y equals 7, you should have x squared plus x plus 3 equals 7. So x squared plus x minus 4 equals 0. Use the quadratic formula. X equals minus 1 plus or minus square root of 1 plus 16 over 2 equals minus 1 plus or minus square root of 17 over 2. Then y equals x plus 3, so y equals minus 1 plus or minus square root of 17 over 2 plus 3. Show those substitute steps clearly on your paper to collect the method marks.
If you wrote x squared plus x minus 4 equals 0 neatly, that gets M1. If you applied the quadratic formula correctly and gave exact surd answers, that's the method and accuracy marks. If you gave decimal approximations, label them and keep the exact form if the question expects it.
Partial credit rescues. If the quadratic is formed correctly but you make an algebra slip solving it, you can still earn M1 or M2, depending on the steps you showed. That's why we write intermediate lines and box them. Examiners can follow your logic and award method marks even if arithmetic slips occur.
Quick recap from me. Decision tree elimination for linear, substitution for linear quadratic, discriminant to sanity check, and always substitute back. Simple to remember and saves marks.
That's your quick win for today. If this helped, share it with a friend who's revising. You'll find more worked solutions and revision resources at jcacademyonline.co.uk. Visit the show notes for downloadable practice sheets that match this episode. Stay curious.
Remember, write it down, don't just think it. The examiner wants to see your method. Trust the process and nail that exam.